All right, we're back for the second part of this video, or the second video, and we're going to explain a few details and do a little show and tell, and try to convince you why you want to get away from alkaline batteries and switch over to lithium ion. You don't want an iCAD. Those are just like too old-fashioned. I think besides the fact that I'm building product around lithium ion batteries, I think that's reason enough to want to get into them. There's a lot of things that you probably have done that I have done. And I left my voltmeter on. It's got a 9-volt battery in it. I've left it on and say, doggone, what a waste of a 9-volter. Now I use the lithium ion batteries, and when I leave the meter on and I forget and I kill the battery, I don't cry. I don't know if you cry or not. I'm just making a joke. I bought this tri-field for the vortex coil that I've built, which is an entirely different project type, and it has a 9-volt battery in it also. I've taken that, it came with a 9-volt alkaline. I've taken that out and I put in a lithium ion battery. But here is something that I just recently discovered that I find rather exciting. The very computer I'm using to make this video with, the battery died. And so I went and bought another battery. It happens to be an Acer Extensia 5630. That's the model number. And I decided, instead of being the good guy and trashing the battery in the recycle bin for used lithium-ion batteries, I was going to crack open the case and see what's cooking and find out what made it work. Well, when I did, I was blown away. It uses I believe they're the same type of batteries they use in the Tesla vehicle. They're 3.7 to 4.2 volt lithium-ion batteries. This happens to be a little package of 4 that came out of that battery pack, and they're still good. There were 6 of them in there. 2 of them were blown. They're mounted in parallel, 2 batteries in parallel. There's 4 here. To give you more current, these are 5 amps. Well, here's one this one's been destroyed, and it came out of that same pack. This is a 5 amp, roughly 4 volt battery. 5 amps. That is an amazing thing. And it's got the word bad written across it because that's what it is. It's bad. And these charge, in theory, lots and lots of times, hundreds and hundreds of times. I don't know whether it's going to be 200 or 1,000, which would be 10 to hundreds, but they'll charge a lot of times. And that's got to save itself. The initial cost for the battery immediately is paid for after 2 or 3 charges. So here I am. I was discovering that I had these size batteries. I looked at it and I said, wow, that is real close to the physical size of those flashlights that we get for $1.50, or $1 if you buy them in quantities, which I did. Bought 100 of these units. They're 9 LED flashlights. They work like a champ. Little screw in top, you throw in your battery and screw the top back on. Obviously I have mixed colors here, but that's okay. Press a button and voila, you got a flashlight. Don't mean to blind you. But it's using alkaline batteries. And alkaline batteries, they degrade. And then you have to go buy another package of alkaline batteries. And I said, wouldn't it be nice if I could take one of these lithium-ion batteries that the battery manufacturers use, for computer battery manufacturers use, and Tesla motor uses, and stick it in there, and then put the cover on. Well, you can see what happens. It won't fit. You can't get that cover on. Even the computer batteries, if you peel off these tabs, they're a smidgen thinner, or let's not say thinner, less tall. They're missing the button protrusion. They're just plain flat surfaced. Just doesn't cut the mustard. Just won't cut it. You can't do that. So I have an idea, and I'm going to get some collars made So screw in a collar, then you'll be able to use these batteries. How do I know you can use these batteries? Well, guess what I found? I have a 21 LED light, and I happen to find, wow, look at that. It uses those 3 alkaline batteries. But this has huge springs at both ends. There's a big spring on the inside and a big spring on the outside. It has huge springs. And I said, well, why can't I just slip this in and be very careful and get this to screw on. And voila. Now when the battery gets left on, I can recharge it. Now the amazing thing is that you can buy these batteries from anywhere. If you hunt and you do some shopping, you can buy these batteries for roughly $2 a piece. You don't always find them at that price. I bought my first round. I bought a whole bunch of these, about 10 of these, and I think I paid $26. So they were $2.50 or whatever. That included the shipping. And then when I went back to try to buy more of these, they were $11 a piece. After doing some more hunting, I found equivalent batteries like this for $2 roughly. So you have to do some shopping, and you can find these particular ones. But the nice thing is that those dollar store flashlights, now this happens to not be a dollar store flashlight. This flashlight cost $4. It was $3.99. It's 21 LEDs. But you find them all the time. Here's a 9 LED. Now watch this. I'm going to make a joke here. I put this down. You can't see the flashlights on. That's how you kill your batteries. It's like leaving the meter on and killing the 9-volt. I found that the same lithium ion, these guys, happen to have another one here, will fit in this one also. This one doesn't work quite as well with respect to, I can't screw the cover in all the way, but I can get it enough to bite. And you can see that it works. And I'm not going to force it. So if I have these type, which are truly $1.50, and they're 9 LEDs also, and I make a little collar, I can turn a 1.5 volt, $1.50 flashlight, 9 LED flashlight, into a lithium ion rechargeable for pennies. So that's the reason why you want to switch to lithium ions, if for no other reason. Okay, so and I made up a couple of chargers that will charge these guys. And then I made a unit right here, a unit that will actually, I dialed in the pot on that buck converter that I talked about earlier, and I set it up so it would charge to 4 volts. So let's see if that's really the case. Let's take lithium here. Actually, I'm going to take these. These are 4 batteries, and they're packaged in parallel. So 2 of them are packaged together. So if I go across the negative terminal, which is, in this case, I'm going to call that negative. And if I go across the red wire, which I'm going to call positive, I can see that these batteries are delivering 3.79. I know that they'll charge to 4 volts. So if I plug in, again, here's that wall module, that 9-volt wall module. If I plug this in, you can see it immediately jumped up to 9.3, 9.4. That means that these things are getting close to being fully maximally charged. This will creep up to 4 volts. And I can prove that by taking off the battery, and it'll actually charge these batteries up to 4.04 volts. So here's another case for this very, very simple buck converter, multimeter type pillbox battery charger, doing its thing, charging batteries that you can use in your flashlights. And if you don't have if you have the little bit better quality flashlights like this one, and thank God I picked it up, because I would have left it sitting there and I would have burnt out the, not burnt out, but I would have discharged the battery. Wouldn't have been a crime if they were just alkalines in there that couldn't be recharged. Turn it off. Alright, I'm going to make a little jump here on my thought train, and I'm going to show you the 12 volt, and that'll be it for this video. I'm going to push things away and show you one other feature. Here's a 12 volt battery. I'm going to use this multi-purpose connector that I made. And I'm going to connect the positive to the positive, red to get it on there, and negative to negative, get it on there. And then get my, I have a one that I preset dialed into. Not that one. I'm looking, give me a break here. Not that one. I haven't gotten up yet, so it's not that one. And what I'm looking for is one of these units. Here it is, right here. I bought a 4-digit display, and I used this 4x12 volt charger. So if I plug this in, I can see immediately the voltage level that this battery's at, and it's at 12.52 volts. I have adjusted the pot inside to charge this battery to 12.65 volts. And I can, because I have a 4-digit display, I can read that kind of accuracy, although I'm not claiming that this, the voltmeter is that accurate. So if I put my half-amp charger that certainly can provide the current, and I didn't mention that these buck converters and up converters, they can handle easily an amp. They say they can handle maybe 2 or 3 amps if you heat sink the IC chip. Okay, so I'm plugging it in, that 12 volt half amp, and I'm plugging it in, and now we're going to start creeping up. It already jumped up to 12.5 to good 12.59. That will go all the way up to 12.65. This battery's been fully charged. The minuscule difference between where it's heading and where it's at is because I just haven't used it. I charged it a couple of nights ago. And it'll get up to 6.5. It'll get up to what I have dialed. I just disconnected it. I have this unit dialed to go to 6.5 volts. Okay, so that concludes this presentation on the battery power, pillbox battery power supplies. They take, if you're really talented, you probably can build one in about half an hour. It takes me about 45 minutes, and that's only because I've got it down now to a science. I buy the components and so forth. So about an hour probably for the average person to build one of these things. And the components altogether maybe 10 bucks, and that doesn't count the battery. And you're done. So go have a good time, and we'll catch you on the next project.